What's going on, people? Hello. Hello. Give people a few seconds to get here before we start. Any questions before we start that are relatively on topic? How expensive is a telemetry license? I don't know if their pricing varies based on the size of company they're licensing to or what. I can't honestly tell you. Is that program made with Electron? I'm sure that some electrons moving around have something to do with what we are seeing on the screen. That is definitely true. I'm not sure how many electrons. Probably at least 6. I have to say, I do like the oolong tea better than the cold brew matcha tea, but the cold brew matcha was worth trying. Give people another couple of minutes to show up. Legacy code bases do have bad aspects to them, yes. We will start in just a minute. Okay, people. Do I ever use CPU hardware events for profiling? Rarely. We are not yet, for example, with this program, we are not yet at the stage where CPU profiling is even relevant. Like, there are many high-level improvements that we can do before we even have to start looking at instruction level anything. So, CPU profiling matters once at a basic algorithmic level you can't figure out how to make things faster anymore. And then you're like, I just need to speed up my individual routines, And we're not remotely there yet with this compiler. Are we going to support SIMD types natively? Probably not. It doesn't make sense. Okay. Thanks everybody for coming by. We've been getting requests lately to upload things to YouTube because most of the streams that we've done for many months have not been uploaded to YouTube. And I always say, well, I'm sort of saving that for relatively coherent work sessions that at least have a concrete deliverable and are maybe contain a lot of visual progress that's easy for people to understand and so forth. And, if I just go in and I'm like randomly tweaking or whatever, I usually don't consider that such a good candidate. Maybe I shouldn't care so much, but whatever. But I had an idea this morning for something that I could do that might make a good self-contained video or series of videos. So we'll see how that goes. On last night's stream, we were cleaning up some things in the compiler, and we managed to eke out a small optimization. We got down, every time I run this timer is going to be a little bit randomized because it's a PC, but we saved about 0.05 seconds off our runtime when compiling this 100 and something thousand line game. 0.05 seconds probably doesn't sound like a lot to most people, but it's 1/20th of our compiler. So if we can just do that 19 more times, then our software is infinitely fast. That's pretty good, right? We did that one in one night, so like 19 more nights, and we have an infinitely fast program. Maybe it won't work that way. I don't know. We'll see. Nobody can really predict the future. But that's what we did. And, when it comes to optimizing the compiler, I'd sort of been thinking for a while that the main thing that needs to happen is these kind of cleanups that I've been doing all this year. And then once enough of those cleanups happen, then we could do some bigger re-architecting. And I think in broad strokes, that's the right strategy. But I also feel like sometimes you need to push forward in directions that you hadn't planned on or that surprise you, because otherwise things just get turgid. If that's turgid, how do you pronounce that? You don't, things, you need to keep things moving. You need to keep them fresh. You need to keep them surprising. And so one of the things that people ask is how parallelized is the compiler? And I usually say, well, not that much. Like lexing and parsing happens in parallel relatively efficiently, but everything else doesn't, and that'll probably be the case for a long time because things are hard to parallelize. Well, some stages of the compiler are definitely harder to parallelize than others, but I was thinking today, and actually it's plausible that we could parallelize most of the stages relatively soon, and that might be fun. There's one stage, the type inference stage, is probably hard to parallelize, but out of our 1 second runtime, that's only about a third of the time here, if you look at inclusive time. And so it's possible maybe to almost make our compiler 3 times as fast before we actually hit the hard problems, and that would be cool. That's not the goal for tonight. I'm just saying in the long term, I started thinking about this and I was like, oh, interesting. Anyway, so if you look at these numbers, well, let me explain what this is, right? So when we hit F7 and compile the game, over the course of 1 second, obviously many steps happen to go from source code to a compiled executable. This is a graph of what all those steps are, right? This is generated by an instrumented version of the program that runs slightly slower than the uninstrumented version. It takes about 1.05 or 1.1 seconds, 1.1 instead of 1 second, but that's not that much of a slowdown because telemetry is a really good tool that's good at profiling. And anyway, you can see here what is going on when we hit compile. So basically the compiler starts up, it loads a couple of small files that are we need to boot. It starts compiling those. So if you've seen preload and runtime support, that's what happens at the very beginning. That might just be like this. And then this is the user level meta program that we start building. Oh, let me say, as I mentioned a minute ago, the lexer and parser are parallelized, right? And so that's what's ending up on these threads. When you see all these little colored bits, that's the job thread grabbing from a semaphore, oh, what jobs can I do right now? Oh, I could lex and parse this file. So it does that, it processes the file and hands back the syntax tree to the main program. And you can see that actually, from the zoomed out view, it looks like it's even occupying a lot of these CPUs for most of that time, but it really isn't. It's not doing a lot of work. like atoms in the universe, it's mostly empty space in there. So that, every time people ask me, is Lexington parsing hard? It's like, no, it's really not. I mean, first of all, you can spread it out among all these cores, and second of all, it like takes no time even on those cores, right? Even if you didn't spread it out that well. In fact, one thing I can point out is all this passing back and forth between semaphores. We're not doing that good of a job of that. So like somehow we're spending 50 milliseconds probably waiting on parse results, or I don't know exactly doing what, but these numbers here are just for thread 12. So 50 milliseconds of our build, so just as much as we optimized away last night, another 1/20th of it is just waiting on these semaphores, and we should be able to speed that up. Like 245 semaphore waits shouldn't be 55 milliseconds. It's not good. So that's a thing to think about. But what I wanted to look at today was this messaging phase. Messaging is when the compiler tells your user level metaprogram about the syntax tree of your program and all the types in there. And if we were trying to be as blazing fast as possible, we would give you a pointer to the compiler's internal representation of your program, but that's not very good for long-term stability and people's ability to use the syntax tree, because we want to be able to change the internal representation of how the compiler does things without your programs having to change, right? Because that would be bananas. So what this does is it essentially copies the syntax tree of your entire program to a similar but slightly different format that is more standardized and hopefully will completely standardize over time. And that, of course, takes some time. So that takes 100 milliseconds to do that right now. And actually, it's actually everything from here down. So 140 milliseconds, right, out of our 970 millisecond compile time. So what is that? This is 15%. So if we manage to parallelize this phase, we speed up our compiler by 15%. Before we even talk about optimizing this actual code, which is maybe possible, maybe not so possible. So what I wanted to do today is start attacking this, and we may not get it all the way to being parallelized. We'll see. First, I want to restructure it a little bit, change the files around, and because once you start making things parallel, you need to be really clear about what data is being accessed so that you don't cause really bad problems. And C++ doesn't help you very much with that. So organizing the code a little bit differently will help. So we're going to do that first. And then we're going to try to parallelize it and see what happens. Before I start talking about the details of that, are there any questions about this little overview, this little overwatch that I just gave? On topic, basic questions about what's going on here. So by the way, the colors in this profile on the left correspond to these colors down here. So yellow, and you can choose them when you instrument your program, right? So yellow is these exports, and you can see them. So like all these little yellow nuggets in here. Oh, I should also say, this is just a hierarchy of labeling. So from left to right is time going by, right? So it takes 1 second to do all this stuff. And then there's a function called do compilation type cycle that takes 1 second. But going down from do compilation cycle, that calls this thing called compiler pump a whole bunch of times. Compiler pump calls various functions like infer types, size majors, and send messages. And so send messages is this thing that we're talking about parallelizing. Perform loads is the thing that dispatches stuff to the semaphores and reads them back. And I'm not sure why we're waiting that long at the beginning. So maybe we need to look into that. But anyway, that's my plan for what to do. And so this this is sort of the main, so this is the meta program starting up on the left, like this first 70 milliseconds. This part, which is about, 850 milliseconds, is the main compilation of the program. And then once that's all done, then we start generating machine code. And that's about 70 milliseconds, it looks like. And then we wait on the linker for like 100 milliseconds. Can we get, oh my God, we're calling compiler pump a zillion times waiting for the linker. That doesn't make sense. I guess we just keep saying, is the linker ready? Like, what? Okay, that's not good. Let me put that in the to-do. Why do we keep calling compiler pump while waiting for the linker? I'll put that in the optimization category because we've got all these other notes that have just, this is how to-do lists work, is you start throwing stuff on them and then you do a lot of them, but it's impossible to get them all, or it's seemingly impossible for a while, So I mean, parallelize on different threads and still not SIMD. Yes. The kind of thing that this is, like copying stuff to a syntax tree, is not very SIMD-able, frankly. You're just converting a tree-based data structure to another tree-based data structure. I don't really know how to do that a lot faster. I mean, in the early days, there were like the MMX intrinsics could help you do basic memory stuff faster, but I don't think that's really true unless you're talking about a large block memory copy. I don't think that's really true now. Although I would be interested to find out if there's applicability there, but no. What we're going to be doing is trying to get to where we can take these yellow blocks out of this stream from left to right and get them to show up on some of these threads up here, because we've got all these nice threads and we ain't using them mostly. Oh, so this one down here, thread 13. I think I said thread 12 before. Anyway, thread 13 is compiling the main program. Thread 12 is compiling the meta program and then running the meta program, which is basically just talking back and forth to thread 13. And you can see, this is sort of waiting on a semaphore probably the vast majority of the time, right? So, yeah, that's what's going on there. Is telemetry expensive, hard to get for indie devs or small teams? I don't know. You would have to ask Rad how much it costs for indies. I don't know. Like we're a slightly bigger company than a typical indie, and have successful games and stuff. So they may not give us price breaks that they might give to somebody else. I don't know. Okay. It seems like there aren't a lot of more questions, so I'll just talk about what I'm going to do to the code. This send messages goes through this class called messenger, which I can show. It's got an H file and a CPP file. And the thing is, the way this was originally envisioned was by topic area, right? So messenger is both sending messages to this workspace and receiving messages from this workspace, right? And the thing is, those are two different jobs that maybe need to happen in parallel. So they should sort of be handled by different code that has no data dependencies between each other, right? And so having both of those happen in one class here is really not a good idea. So I want to split this into like message export and message import, because I use I use the terms export and import in here. So the first thing we're going to do, we're not even going to try to parallelize anything yet. We're just going to split this file actually into 3 files, because here's the thing. The vast majority of this header file is defining these data structures that are basically the protocol that we use to talk to the user program. Don't tell the language server protocol people this, but you can actually do a protocol in binary, and you can do it in memory. It doesn't have to be over a freaking network socket. So that's how we talk to the user program. And all of this stuff is going to be in common. Like the message sender and the message receiver both will want to see all these things. And these things won't involve any data declarations. So we will not be afraid to include the include file that holds this. But this guy, or the part of this guy that exports, is going to want to have data structures that are private that nobody else can see easily. Because if people accidentally use them, then you get race conditions. And the same for the message importing. So we're going to have like a messages.h, and then message export and message import. And we're going to split the header file into 3 things. And because this is C++, that means we're going to have a lot of ugly compile errors until we split the CPP into 2 CPPs. So we're going to have more files, roughly the same amount of code, and better partitioning for the job that we're going to do. Okay. Meanwhile, I'm starting to get hungry already. So even though we're going to post this on YouTube, I'm going to fill a couple minutes with ordering a pizza while I give a little more space for people to answer questions, so that I can just do this initial burst of really not fun refactoring and look forward in my heart to the delicious pizza that will show up. So are there questions? If you're watching this on YouTube, you can fast forward past the pizza part. What kind of pizza am I ordering? The same kind I always get. Which I will post on the Discord for elite frequent flyer members. Go. No. Okay, hold on. This is so confusing. So there will be no support for SIMD operations. Well, you would define them yourself. There'd be intrinsics for it. Low-level intrinsics, and then you define the higher level operations yourself. Okay. Finally found the right selection. So good, man. We're going to go even greasier than last time. C++20 is adding using enum. Great. Seriously, though, is public just an old habit? What do you mean? I don't understand. Where? What are you talking about? Why am I not using a single structure and a union inside one for every message kind and a type instead of using classes? Why would I do that? What advantage is there to doing that? Is it the ask translation that you want to thread, or is it the actual sending the message? Well, it's we'd like to thread both, but really it's probably mostly the syntax tree translation, because the thing is, we still have to pass, if we're going to multi-thread this, we still have to pass these things to the thread that's going to do this processing, which is about as expensive as passing them to the user program anyway. So it's a little bit questionable how much you could save there. Will receiving messages be threaded or just a single thread? Probably just a single thread for now. Although it happens, actually, it already happens on a separate. Oh. No, actually, we're going to want to parallelize that too. The thing is that the only kind of message receiving that's expensive is syntax tree modification, which hopefully you're not doing to your entire program. If you are, then of course we can parallelize that later. But it's not a priority because, for example, right now, we only do that to small parts of our program, and so it doesn't cost very much. It's sending the messages that costs everything. No need for public when deriving. Why do people keep talking about public? Oh, down here? What? Guys. It's like yeah. Oh my God. Yeah. I mean, it's just, this is the problem with all of programming, is that people seize on little things and nitpick on them. It's like, look. So let's start doing this. We are going to make a messages.h. Actually, anytime you start changing a bunch of files around too, it's a good idea, once you check them into source control, to make sure that it builds correctly on another machine. Of course, we have a continuous integrated system to do that, but I want to see it with my own eyes. So I'm also going to have my laptop do that, which means I'm just going to make sure it's updated to the current version so that this doesn't take a long time while I'm over here doing this. Because also, if there's a problem, it's much easier to diagnose when you've got like a full thing in front of you and not getting like messages from your system. All right. So all these horrible messages that are not at all tagged unions and that use public. Oh my God, dude. We use public to derive a struct from another struct. That's just the worst thing in the world. Oh my God. Did you see that? Emacs just garbage collected for like 2 seconds. All right. So there's that. How to access SIMD registers if you can define your own low-level operations. We're going to figure that out the best thing. I don't know yet. Okay. So probably all this goes there. And I should call it message exporter to stick with the naming convention, even though that's not great. All right, so we're going to go here. Then we're going to go to message importer.h. And we're going to go there, and we're not going to forget to add these. So okay. We still need the CPP files, but whatever. We're just adding those to source control. And then messenger.h doesn't matter. We're going to delete that. Okay. So let's go to message exporter and okay. Why is this even a class? Good question. I don't know. Okay. We need a self-host question counter, and then we can graph that over time on GitHub. Like how many times per hour that people ask about self-hosting. All right. So anything about import, we're just going to delete. I'm not sure about these. That might have meant exported. Okay, do import statement. Okay. Flatten nodes, flatten procedure bodies, current import nodes. That's import related. Okay, and then message importer probably is going to want to use these same allocate routines. I don't know. We'll see. We'll figure out. We might have to factor those out of these guys. Import, import, import. Export, export, export. So I assume something. Oh, import blocks. That goes from here. So this goes from here. Something like that. We're just gonna wrestle through the compiler errors and see what happens. These might actually be categorized incorrectly. We'll see. In fact, this down here might. Okay. Okay, stream add message exporter, message importer. Okay. And then, of course, because for some reason we use this, we have to add these. Here. And then we'll build and we'll get a bunch of errors. Oh. Can't even include messenger.h because, well, let's, like, what do these people even want? Why are they including messenger? We're not going to worry about it yet. We're going to get those files to build, the new ones. And then once those build and we know what's in which one, we can go back and remove these includes and see what these guys are trying to reference and then give them the appropriate includes. All right. However, here we're going to go messages. All right. Okay. Who calls strings match? Make unique file name. I don't even know what that's for. Like, why is that here? We have other strings. I guess I left it local because, like, it's a weird one that crosses types. But we're just going to put it here with these other ones. And our compile time will go up even further in C++ because we're including that everywhere. Okay, so that strings match, that strings match. Let's replace messenger, message, importer, replace messenger, message, exporter. Okay. Now, oh, Emacs garbage collected again. What a wonderful editor. Garbage collection is great. Okay, export. Get rid of everything that has export. I don't know about. Okay, this is exporting because the result is code argument. Code argument is the exported version. This is an import, though. So this is export. Fill from is import. This I don't know about. Okay. These I don't know about. These I don't know about. Compiler wait for message. That's import. That is import. So that is not here. And it has to ask this export, so that's not here. Not there, not there. Ensure exported. Do export. And all this, all this, all this is gone. And then this is import stuff. And then make unique file name. I don't know what's going on there. Okay. So here, similarly, export stuff. And then this is import stuff. Okay. So exporter 1,000 lines, importer 1,000 lines. Not that surprising. Oh, we should have done a line count before we started, but oh, I could do it on the laptop. So the laptop says 48,352. It's a different version of clock, 1.64. $48,407. So we're 50 lines up, which isn't that surprising because like we duplicated some things between these files. And just adding includes and whatever, it just adds lines. Okay. So, God, people are still talking about public in the chat. Oh my God, people. No, I'm lumping it into the category of completely meaningless things that waste your time to talk about. Like every time you talk about something like that, you're paying the opportunity cost of not thinking or talking about things that are actually important. That's why it bothers me. Okay? If you want to know why it says public there, it's because I strongly dislike the object-oriented parts of C++. I do not think about them. What I do is I type the things that I have memorized that do what I want to do, and I don't think about 95% of the features or what the possibilities are, okay? So I know what public whatever does. I know that I've been bitten by annoying and stupid compiler errors when I don't put public there. So I put public there and then ignore the rest of the programming language, okay? It allows me to get work done. That is why I do it. And that's the answer for most things about what I do with C++, right? So, but the fact that you can watch a programming session like this where we're doing interesting things and that most people just start engaging in this discussion about whether a keyword should be there or not, like that's super bike sheddy. That's like arguing over which shade of blue the shed should be. Yeah. And it's not any one, I don't mean to blame any one person for that, because again, it wouldn't be that annoying if just one person did it one time. But it's like what all programmers do in the modern day all the time, and it's why software sucks so much, frankly. So, no, I mean, I know it wasn't originally addressed to me, but people are still talking about it half an hour later, dude. Like what, why is it still happening in chat? Like, why is this still a topic? Does the existing parallelization scale to relative to number of available cores? Yeah, I mean, it tries to. Like, we set up some number of job threads. Actually, it might be hard-coded right now, but it's very easy to say, how many physical cores do you have? Okay, we'll spin up that many threads or that many times 2 if you want a hyperthread or whatever. The thing is, we just don't even need as many cores as we start right now. So it's like, it's not even worth trying to max out your machine by seeing how many cores you have, because we could barely use them right now. And so what part of this is about is enabling that further. Am I completely against like OOP? Well, not completely. But I think most of the features in C++ are anti-features at this point. Like I use a small subset of C++, And the subset that I use in very constrained ways. Because I don't feel that that the choices about what features go into C++ and how they work, I don't feel it's done in general intelligently or wisely or competently, to be frank. So, yeah. All right. So now we just sort of have to figure out some things. Like, I was not sure up here. Like, for example, make unique file name. I'm not really sure which of these files that should be in, or should it be outside. Let's take a look at who calls it. Copy location info to an ast. Okay, so this would be an import job. That's it. It's an import job. So I guessed wrong. That's there. It's gone from there. Oh, maybe I didn't guess that wrong. Okay. Okay, what are some other things we weren't sure about? Oh, that copy location info is probably still in message exporter. Nope, I got rid of it. Okay. Let's just try building that. Why is it still building messenger? Oh, we didn't delete messenger. Messenger.cpp. Do these, don't tell me these build. I guess they're in some separate phase to not build until the other stuff builds, which is not what we want. So, yeah. Have I looked into why Clang and GCC are slow? No, I mean, it's just all modern software is really slow. Clang and GCC are less slow than a lot of other things like Photoshop, but they're still pretty slow. All right. So message importer is not a class or namespace name. Why not? Really? Oh, because I didn't do the replace here. I don't know how that happened, but okay. Fill from code arguments. Did I put that in exporter? Yeah. Come on, I just want you to build these files. Find procedure body from exported. Okay, let's take a look at that. Find procedure body from okay. Yeah, this actually goes, this is an import function, and the problem that we have, all right, oops. This is going to get hairy when we multi-thread, but it's not, it won't be hairy yet. All right. So here, I'm going to change this Okay, and then this is at initialization. We're going to make, oh God, we knew these things. I guess, see, this is stupid that we knew these things, but like, we would have to take the include files up here to not construct. It's the stupidest thing about C++. I guess we'll keep this for now. Eventually, we should clean this up and not do this. It's one of the many things about C++ that's a waste of everybody's time. It's just that we have to pay more compile time in order to not allocate these this way. Okay. Syntax error code block. Oh, yeah. Exported procedure record. Right. Do we use this? Exported procedure. We're just going to put this in messages for now. This might not be the play, but that's what we're going to do. Okay. Message importer. Let's call it importer. Line 2100. That's not renamed. $22.85. Message for load directive. That would be an exports. Wait, message is compiler get message file. Okay, this is not good. So you can see we're not actually using messenger here. This means this is a macro to use the messenger's pool to allocate a compiler message. And the problem is, once we're in separate threads, we're not going to, that's not a good play. We're going to want to use our own memory for that. So I guess I was doing that to keep all the memory in the same place for all the messages, but it's not the play. Okay, so for now, we'll keep it, because we're not threading yet, we'll keep it the same. Got a declaration. All right, fine. Message sender. Oh, message exporter. That's what it's called. That's all for now, but we're going to have to hit that later. Okay, so interp compiles, that's good. So now we go back to this. Add flattened node. Uh-oh. Okay, nobody uses that. Good. Okay, this whole allocate static sized array, and I think this might be used. No, nobody in importer uses them. I guessed correctly. Message exporter, undefined type. Really? What am I doing? My brain cells are not working because of the lack of pizza. Oh my God. 6 minutes away already. Dude, this is the fastest Uber Eats pizza. This is going to be awesome. This is going to be awesome. This guy deserves every cent of the tip that Uber preemptively charged me for some reason, because they do that now. All right. Whoops. Wait, really? All right. So what does this guy want it for? Whoops. Nothing. Okay, great. We saved a line of code. What does this want it for? Something. The actual messages, I guess. All right, because this was, okay. Yeah. Okay. First, let's assume we don't actually need it, but we probably do. Three minutes away, people. All right, I'll be back. As Arnold Schwarzenegger once or twice said, and then we will continue. As always, when we're taking a short little pause, let me know if you got any questions. Wait, now it says 4 minutes. I guess there's a little bit of traffic. Guess there's a little bit of traffic. Didn't even need it. Didn't even need it. Okay. Okay, now it says 2 minutes. I'm going down. Back in a minute. Oh, yeah. We got some pizza. We got some pizza. Yummy time. Yummy time. Is there a video of implementing the font rendering? No, that's just ported over from stuff that I implemented in the Witness, which is ported over from stuff I implemented in Braid. It's from a long time ago, originally. Wow, this is spicy pizza. It's a spicy meatball. I need to go cut this slice in half. It's massive. This really isn't 65% bread. It's really mostly toppings. Okay, so we are not too far from compiling, I guess. I feel like explain probably doesn't need it, but maybe it does. This probably does, but who knows? Yep. And then this probably does not. Yep. Error loading type library / DLL. What? What does that even mean? Oh, I typed import because I'm in the wrong programming language. Okay. All right. Oh, we're making the telemetry build, by the way. Okay. Now, let's make a release build, and it should just run. Ta-da! So as every, oh, I screwed something up. Importing doesn't work. So exporting works fine. Maybe we're not modifying anything in Sokoban right now. But this attempt to modify a procedure failed due to incorrect address. What that's about is we probably duplicated like this. Yeah, this exported procedure bodies and flattened nodes. I think do that. Yeah. In fact, I just typed the wrong thing here. All right. So there you go. So as the test-driven development people will tell you, you can't possibly refactor code without breaking tons and tons of tests, and that's why you need the tests. You need to write the tests first, because programming is scary. And if you change your program, it won't work for 3 weeks. Split messenger into message exporter, message importer. So then as soon as I check this in, I'm going to make sure it works on my laptop. Oh no! My Visual Studio 2017 on my laptop is telling me to sign into my Microsoft account. And I don't remember my password to my Microsoft account, of course. Oh, now I have to use a product key. See, this is why software is so good. Well, you know what? I don't know how to look up a product key for Visual Studio right now. I certainly paid a lot of money to have one, but I'd have to dig through my email to find it. So I can't actually compile on my laptop now. So hopefully I didn't break this for the rest of the company. Thanks, Microsoft. I wonder why I'm doing my best to get off your software. I think if we all had a little bit less Microsoft software in our lives and a little bit more pizza, everybody would be happier. Build passing, okay. The build server claims it's fine. That's going to have to be good enough for me. Since my laptop is basically now a brick for the purposes of this stream, it has been closed. It is now supporting my pizza plate and giving me additional table area. What do I think about a subscription-based IDE like Visual Studio, but the difference is it just periodically sends pizza to your customers? You don't want that, because the pizza that Microsoft picks or that Adobe picks is not going to be the pizza that you want. Okay, let's just put that out there. you're going to get like Pizza Hut or something worse than that. You're going to get like, so Amazon will buy it, and then you'll get 365 brand frozen pizza from Whole Foods. That's really not what you want. Okay. Remember when Whole Foods was good? Does anyone remember that? Whole Foods was pretty great in like 2002. Okay. You don't remember that? There was a time when you could actually buy fruit and vegetables at Whole Foods, and they'd be like kind of fresh and kind of okay. They wouldn't be like stale cardboard fruits and vegetables. All right. I think now I put the pizza in the refrigerator and then we get serious. So we now have our situation split. Into two structs. Now, this still isn't as walled off as we might like. Because first of all, lots of people are importing message exporter, which is worrisome. We probably shouldn't have that, or including the file for message exporter. And message importer is speaking directly to message exporter by like looking in this array. We could just throw a mutex around that for now. But we might see some contention there, and it might be a little bit error prone, but we could definitely do it. C++ doesn't really help you with that, but we could be okay. All right. Maybe we're not going to put this on YouTube because I'm spending a lot of time today not doing anything. Is that an argument with missing T? Probably. We're argument. I see lots of arguments with a T. I don't know what you're talking about. From code arguments. What are you talking about. Although, actually, yeah, this probably shouldn't be in, I don't know. Oh, you mean this? The T's over here. What are you people talking about? What are you talking about? Okay. Is polymorphic. That's a little bit scary, so we don't want that. Okay, let's see. We need to start siloing these things off from the rest of the program, which means like a lot of these includes need to go away. This needs to go away if we could help it, or it needs to be a verified Amazon Prime member. Okay. I think the way we make it a verified Amazon Prime member is we put it in the header file. Thus increasing our compile times even more. Yay. Yay. Okay. Okay, this one. Oh man, now we're playing with overloading. Frack. That's not even the one we wanted. Okay, hold on. Oh, I guess it is? No. Where is this polymorphic function for a lambda? It's in typer. What? Look at that. That's so ridiculous. Okay, that's going to go there. It's going to go to polymorph. Is polymorphic. Like, what? None of that goes there. This is the thing that makes things polymorphic, not... Yeah, whatever. Okay. So we've done that. This is not even. For avoidance of doubt, I'd rather just do this straight in there. Like, literally all we're doing. Yeah, I don't know why I bothered factoring that around. Okay. 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 Why pretend that this has a destructor? It's just not the way it's ever going to work. In fact, let's go to an init. That's all we're going to do there. Oh no, somebody says, why are you not using a constructor? That's not modern C++. Oh my God. How nasty is optimizing for different x86 CPU families? Do you even do that? We almost never do that. I mean, maybe RAD does that. I don't ever do that. All right. So do we need bytecode runner? I hope not. Type table, ugh. Okay. This is gross. All right. So okay. So there are two sets of data. Of things that get messaged. Or that's the wrong way to say it. Of the information that gets exported to your metaprogram, there's sort of two different kinds. There's the type table, which is probably very frequently accessed at runtime as well as compile time, because you have a little type info thing. And then there's the syntax tree for your program, which is probably less widely accessed and is not available at runtime unless you were to serialize it yourself and load it back in. And those are I guess there's the question of how do we organize this then? Because if the type table there's been this long-standing issue where we kind of are not sure why types are not already added to the type table when they should be or whatever. Like here, in principle, by the time things get through the size pipe, which is before they get to us, they're supposed to have had this done. Now that may not be the right tactic. Maybe we should do it in here. Except that things like type of get resolved by the type checker. There's more interaction between these types and the rest of the system. So I'd kind of rather, for now, have them not be parallelized. And so I think my job needs to be to make sure that we don't need to do these in here. Like they need to get added before we get into this code. And that may be non-trivial. For all I know, that could take the rest of the night. Who knows? So let's look at these other things. and see if we can get rid of them. Token types. Maybe we don't need that. No. Good. Every include we can get rid of is good. Parser. Why is parser here? Dude, this Visual Studio bug drives me nuts. Okay, parser, gone. Standard lib and string, do we really need those? Gone. Bytecode builder. Constant storage segment. Uh-oh. Oh, but that's in typetable.h anyway. Data segment. All right. That's probably going to break. Yeah, oh my God, dude. I hate C++ so bad. I hate it. I guess we can like... You know what? Instead of we could pragma once that and stuff, but I'm just going to do this. I'm just going to say... So let's make sure, so for type table, we're adding, that's all. Okay. So if earlier parts of the pipeline make sure that things are added to the type table, we shouldn't need to reference it from this file at all. And that'll make us happy. Let's see some of this other stuff. Concatenator. Do we use concatenator? No. Okay. Typer. Maybe we don't need. I feel like we're going to need that for something, just because it's so much stuff, but maybe not. No. Oh my God, this is great. Okay, interp we need. Although maybe for not that much. Especially because we're going to get rid of. I mean, we could grab pointers to these things that we need. So like type def void, we can get. Interception flags can be set on this. Type def poison we don't even frickin' use. We should in the future, but we don't. And yeah, these are mostly type table adds. Oh, and report error. But that can be... That can be a very specialized, narrow tunnel situation. Like by the time you report an error, you've given up on life. So, okay. This is positive. We should be able to remove interp.h from includes once type table is gone. Okay. I mean, not immediately when type table is gone, but given a little more work. And then we'll just have general, which is, you know, some stuff that we need, and then messages and message exporter. That'll be good. That'll be good. All right. So I guess the thing to do is to just I mean, really, we should just go to the size pipe or something. Let's look at type table. Okay, that's that things have been sized. Type table add, that happens in size majors, but it doesn't seem to happen very early on. Maybe I we don't do this early out thing. So type table add should be happening for everybody, which means if this is still a problem and we need it in export, it means someone is not being hit by it. So what I should do is assert define type info before we type table add. And we're going to just see where that breaks. If it doesn't break, then we obviously fixed something a long time ago. I assume it will break, and then we'll just need to see why and what to do about it. Very quickly it broke. Okay, what is defin? It's probably one of the basic things on interp. It's a pointer to a struct called new string, which I think is in preload. Line 438. So it's that, which is just flowing through our pipeline. This might have been created directly by interp. Does anyone use that? Oh, I guess it's in Typer. Okay. Let's just see where this gets created. value. All right. Amazing how much slower it is once we put a breakpoint in. Really long time. Come on, people. Maybe breakpoints on thread local storage are like extra slow. I don't know what's going on there. Because I started putting it up here instead of down there, and maybe that's a mistake. All right. Where are we at? Resolve ident. Okay, so we're setting this on an identifier. So why isn't that identifier? Like, we shouldn't have to explicitly add things to the type table all the time. Oh, it was already added, and we changed the type later. This seems bad. Why are we changing the type later? We thought we knew the type. It already was a pointer to something. Pointer to something. That's messy. Like, I definitely know there's some cases in the code where I set a type on something and then reset it later. But, like, that shouldn't happen. It certainly shouldn't happen and yield a different result at different times in the pipeline. Like, someone went off and added this to the type table already. Consume U8 in length. Okay. Wait. Oh, this is the thing that we are dereferenced from. Why are we changing that? So we're saying whatever dot count. It's probably this. Let's see. Line 177. So we're saying input dot count. Input is a pointer to string. Why? Are we oh. Okay. So what we're doing this thing where we fake out. We substitute a fake struct. Okay, this struct is going to be, right, this is that new string. All right. So what we do, things come back to bite you sometimes. What we do when you say something .count, this is a string type, right? It doesn't really have member called count, but what we do is we say, hey, we've got this thing in the preload called new string that actually defines the format in memory of the string. So just pretend you're dereferencing that struct. How do we pretend you're dereferencing that struct? Well, just change the type of that thing to this struct. Okay, this is bad for a couple reasons. The first reason it's bad is that your user level syntax tree is going to see the modified type if we actually do this. That's bogus. Secondly, well, if this happens after we've already done the thing, it confuses the issue of like, have we already done the thing where we register this type in the type table or not? Because we appear to be changing it after that point. So that's not okay. What's the problem with simply defining string as a struct rather than making it a magical primitive? Because if it's a magical primitive, the compiler knows what it is. It can generate better error messages. It can be faster at handling them. And it can do special case things with them like the relative strings that we do. It fails to get the code point for a space character? I don't know. Yeah, it's just like strings are a special case enough thing that you just want the compiler to know about them, right? That's all. Like, you know, so when you subscript a string, we can do a bounds check on that. Whereas if it's just an array with a count and a pointer, the compiler doesn't really know that the count bounds the length of that pointer. I mean, I guess we could make new syntax for that or something, but you know, you start, it's not as simple as just defining it as a struct. You start having to make new things in the language to start to get back what you lost. Okay, so this is not okay. What we have to actually do, or what would be cleaner to do, and we wouldn't be lying to people about it, would be to set, so set on the ident, I guess. We'll have another, it's a shame to use more memory on idents because there's so many frickin' identifiers in a program. But we could have a new thing that just says, the substitute type for a struct dereference or something. Okay, this is at line 7430. I'm getting tired. We might do a break and then come back again in a little bit. Because I want to be like, I need to be alert and sharp, and this pizza is putting me into sleep mode, honestly. Okay, so let's make sure that we didn't screw anything up and that we still build. We still run the build engine by Ken Silverman. We totally don't. Oh, because of my assert. Who am I kidding? Okay. Wait, what? It's that one. We all know it's that one. All right. Maybe that's not the only problem. Wait, my assert isn't even there. Did I screw something else up? Oh my God, people. What did I do? I need to get it in check-inable situation before we attack this. What is happening? What did we did a lot of things. We did init functions. We did moving around is polymorphic function. Well, let's just see where it crashes. Here. Oh. Because it can be null, as you can see clearly from the previous lines. Durr. Like, hey, we're inserting a line that looks exactly like the previous lines. Do you think we should read those previous lines and see if there's anything relevant we should care about? Nah. Nah, let's just, whatever. All right, so this is good. Is good. Let's do the test real fast. And then we're going to do this thing on identifier, which is gross. But yeah, as type definition, struct dereference substitute type, which is null. Okay. And then this still isn't going to solve the problem that we don't register that. Because even if we change the type table registration code to like look for this member and add it, it appeared to us that this was happening later, although maybe it wasn't. I don't know, dude. Oh, if the thing on the left, okay, it might be that the thing on the left was inferred, but the ident hadn't been yet. Yeah, okay. It might naturally resolve itself, but we're putting it there in case it doesn't. Okay, so for this thing, we instead say ident struct dereference substitute type is struct defin Oh, it's pointer. Is this a pointer type? Otherwise, although we don't even need to do that. So I think the bytecode builder could just handle that, but whatever. And then here, it's just the struct itself. Okay. So then, when we're in bytecode builder, okay, if we try to just use this right now before we do anything, it probably won't work. That said, maybe it will. Maybe it will, but probably it won't. In fact, we probably fall through down. We might type check fail because something further down in this function might expect that type to be replaced. No. Okay, I'm kind of shocked that we didn't need to poke that at all. But I guess we don't. I guess we do the equivalent thing in bytecode builder. How do we get these? So we have this whole big piece of code. Like, hey, if you're asking for count on something, and it's a string, oh, and if it's constant, okay, new string desc, right? So we don't do that here. Why does it work? Do the tests fail? Like what? I am shocked by this. Okay. We're attempting to index a nil value. I really don't understand why that. I mean, I guess maybe that's just a legacy thing. But we need to be careful. I mean, I'm very happy if that's a legacy thing, because then I don't even need to add that member. What I need to be careful about is that maybe some type checking here depends on that. Let's run a debug build as well. Yeah, I'm feeling kind of tired, like woozy or something a little bit. Okay, that makes sense. That we're asserting or just dying. That makes sense. I am not surprised. Okay, we're asserting. And the assert is killing us because, yeah, okay, this is what I expected. I don't know why. Did the release build just fail to compile or something? Like, I don't even know why our programs worked, because it wouldn't have had the correct type. So wait, struct type is set, so it wouldn't return -1, but struct desk is not set. Oh, I guess we don't need it, because the entry declaration that we resolved on tells us the offset from the base of the type. So we actually don't need. Oh, we need to know the. Okay, hold on. Yeah. If we don't actually use struct type, I'm just going to factor it out. Right? Because it's just that assert crashing us. That's cool. I'll comment why. Oh, emit call of using function. Emit struct dereference. Oh, that's us. So obviously that doesn't, and that's just for emit struct dereference. Yeah, nobody needs this. Nobody needs this. That's great. That's great. That's great. That's great. Because it means we don't even need this source type variable here. Well, we need it for that, but we don't need like this. Dude, this is gonna be baller. We don't need this, don't need that. Don't need that. Okay. Probably missed some there. Okay, so we didn't need to do the thing that we did. We're deleting code. Deleting code. We are running fewer instructions. size on struct type. Why were we init sizing here? Because we thought we needed it for some reason, but we didn't. Oh, well, there's that, but whatever. Not worth all that to have that assertion. We can put that assertion at the calling site. Okay, this is good. So this thing that we did goes away. We just don't even need this. We don't need any of this. At all. That's a win. That's a spicy meatball. There we go. Still compiling. Still running. Still testing. We've got a net line decrease here. That's good. It's good action. Okay, yeah, I'm going to take like a nap break situation, and then we'll come back and continue what we're doing, which is to silo off this code so that we can make it more parallelizable, which may involve further going to the weeds. Oh, I wanted to document this. We don't actually need to know the type of the struct we are dereferencing, since the member declaration contains the memory offset. This is good because in type checking, sometimes we use structs to stand in for strings and arrays, so there is no official. So the type on the left of whatever operation we're performing would not even be a struct. Calling pseudo structs. Used to alter the type of left to deafen, but this is messy and not a good idea. Turns out we do not need to run those. Awesome possum. See, we started somewhere, we ended up somewhere totally different. I'm going to check this in. Some cleanups. And then we'll go back real fast and we'll turn on our assert, which is still going to go off, possibly even in the same place. Where was it? Message exporter. That assert. Maybe it'll go off in a different place. Actually, it won't go off in definitely the same place because we're not creating that type anymore. Okay. Well, wait, how is this? Okay, it is an assert, right? Not a crash. Yeah. Okay. This was created by the compiler at startup. So, or maybe not at startup. It's also a pointer that was created somewhere. It's a pointer to an integer of some kind. All right. You can see very quickly where this is. So before we got to 16119, we got to 16145, we got a whole 26 things further. At that rate. Any approximate time I'll be back? No, I'm not sure. Do I play any fighting games? Not really. It's not my favorite thing. Are pseudo-structs like proto-buffs? You know, since proto-buffs are so versatile, I mean, you probably should use them for pseudo-structs, right? I don't think I'll be offline for too long unless I accidentally fall asleep for the whole night, but that's not the plan. Not the plan. Why does this take so long? I just wanted to have a little thing to give my subconscious mind while I go rest. Will I ever sign a deal to get Tim as a character in Super Smash Brothers? Hard to say. Hard to say. Okay. Inferred types for unary expression. That's really weird. Like, why is this unary expression not print line 279? Oops. It's that taking the address of C. That's just a random expression in the body of a struct, so, or in the body of a procedure. So somehow we're just not adding that to the type table. I mean, maybe most things get added to the type table in message export right now. I mean, if that doesn't, I'd assume most things don't get added before that. And so maybe if we add it before that, we're not going to save as much time as we would like. So let me think on that. while I take my break. Thanks very much for coming by, and I'll start up again pretty soon, hopefully. And we will do more working toward parallelizability. Who knows if we will get there, but we will try. See you in a bit.